Okay, so this is still 5.2. Continued, there was a second note sheet, and I wanted to break the video apart into two parts because it was getting too long. So this is just a couple more examples. I'm going to talk through this one, and then it would probably be wise if you pause the video. Okay, so I'm going to talk through this first page. And then the second page, it would probably be wise if you tried these two examples on your own to see if you can do it right. All right, so let's talk through this one. Example 2 says, graph and label the vertex and the axis of symmetry. So here's my graph. Here's my vertex right here. We're going to label it. And I already have the axis of symmetry identified for you on the diagram. So remember, when you have a middle term, you have to find the vertex by using this, small formula, negative b over 2a, to find the x, and then find f of that value, or substitute the value of x into the original function to get what the y is for the vertex. All right, so this thing opens up. Leading coefficient is positive, so it opens up. We got a smiley face. The axis of symmetry, you get the axis of symmetry by setting x equal to negative b over 2a. Folks, you have to identify the a, b, and c. So if I look here, this is, this is in the form. Let me choose a pen here. This is in the form a x squared plus b times x plus c, right? So my a is 1/2, my b is positive 1, and my c value is 3. So I'm going to erase that so you could see what I'm talking about. So again, right here is a, positive 1/2, b is positive 1, and then c is 3. Okay, so we're going to identify that because we need the a and the b to substitute in here. And sometimes you get fractions. It's okay to get fractions. You should know those little rules of how to work with fractions. So I'm going to substitute the 1 in for the b. The negative is that negative. And then I'm going to substitute the 1/2 in for a. Now, 2 times 1/2 is 1/2 of 2 or 1. Okay, so this is negative 1 over 1, which equals negative 1. So the x part of the vertex is negative 1. That's also the equation for the axis of symmetry. Notice I have it up here. Okay, I labeled my axis of symmetry. To get the y value, you're going to have to substitute the negative 1 into this function up here, right? So this right here is me substituting in a negative 1 for that x and for that x, okay? Don't make this be a difficult thing. It's not that much of a difficult thing. Okay, so you're going to sub in there and find that the y value is 5 over 2. Remember, I want fractions. I'm not interested in decimals. Please don't give me decimals. Okay, the y-intercept is always 0, comma c. You're going to put a 0 in for the x's. All of this right here is going to go away. Okay, all of this right here is going to go away. It's going to equal 0. When I put a 0 in here and square it and multiply it with this, it's 0. It goes away. Plus 0, again, it goes away. So I've got 0 plus 3. All right, so my y-intercept is 0, comma 3. All right. So I could graph my vertex, right? X is negative 1. 5/2 is 2.5, so I'm going to put a dot there. And then my y-intercept is 0, comma 3. And now I can use the axis symmetry to help me find this. That's why that point's in blue. Okay, then I'm going to need one more point. So I'm looking already like I've got this baby parabola. I'm going to go over and maybe pick, I don't know, x is 2. But then you have to find what the y is when x is 2. And again, you're going to substitute a 2 back into the original equation where these x's are. Okay? So you're going to have to square the 2 and get 4, and then half of 4 is 2. And then 2 plus 2 is 4 plus 3 is 7. That's how we get y is 7. So this ordered pair is the ordered pair 2, 7. And so we're going to graph that. X is 2, y is 7. And then we're going to use the axis of symmetry. This point is 3 units on the right of the axis of symmetry, so its corresponding point would be 3 units to the left. And then you graph it. All right. Talking about this part of the notes. Finding the minimum or the maximum value of the function. You're going to graph the function as before. You determine if there's a min or a max, and I know I spoke about this in the other part of the video. You know, if the parabola opens up. If it opens up, then you have a low point or a min. If the parabola opens down, then you have a high point or a max. Okay, so keep that in mind. This value is the y coordinate. So we could say the max happens at whatever x is, and the min happens at, or the max value happens at whatever y is. So in this example up here, of course, we're going to label the vertex. The vertex was what? -1, 5/2. There's my vertex. The min value is this. It's the y. And then we're going to say the min happens at the x, -1. Okay? The min happens at the x value. The min value is the y value. And that's what this part of the note sheet is all about. Go on to this one. I highly recommend that you pause and try to do this on your own, and then turn the video back on to see if you can get the correct answer of what I have. Please remember that you do need Cartesian coordinate paper, aka graph paper, to do this. Okay, please do not be doing your own makeshift graphs. I've been telling you and asking you to keep graph paper in your notebook. I have it in class. All right, graph the function and find the max or the min value. Hopefully you did it on your own. You paused the video. What color do I want? I'm going to use blue. All right, because this is negative, the parabola opens down. Okay, and when this opens down, you should have a max. Okay, that's going to be at the end. Right here it says max, y equals 1. Max at, looks like x is 1, 2, 3, 4, right? My vertex is 4, 1. Max at 4, max value 1. All right, you got to find the equation for the axis symmetry. That's negative b over 2a. Folks, yes, this is a fraction, -1/4. Big deal. 2 times a quarter is 2 quarters or a half. Remember, to get rid of this 1/2, you're going to multiply the bottom and the top by the reciprocal of the denominator. So that's 2 over 1 negative. 2 over 1 negative. Okay, and then -2 times -2 is positive 4 over 1. All right, don't let multiplying and dividing fractions make this difficult for you. This is not hard to do by hand. If you need a lesson on that, then reach out to me. Come in a Google Meet. But again, this shouldn't be something that's too terribly horrible for you to master. The vertex. Well, we know the x part of the vertex is the same as the equation for the axis of symmetry. So the x part of the vertex is 4. How do you find the y? Well, you're going to take this 4 and you're going to sub it into the original function wherever you have an x, right? Because you're really finding f of 4. We've done that already. So you put the 4 in. You square the 4, you get 16. And then you take a quarter of 16 and you get 4. Plus 8 is 12. Actually, this was -4. Sorry. Plus 8 minus 3. So the y value is 1. So there's our vertex 4, 1. The y-intercept is always 0, c. You let the x be 0 and solve it for y. Okay, if I let the x be 0, this is going to go away, this is going to go away, and I see that I got 0, -3. for my y-intercept. So guys and gals, you plot your vertex, you plot your y-intercept, you identify your axis of symmetry. Since this point, which is the y-intercept, is 1, 2, 3, 4 units on the left of the axis symmetry, then its corresponding point would be 1, 2, 3, 4 units to the right. Bam, that's why that point is right there. You choose another point. I would highly recommend that you choose a point that's between your vertex, right? You're putting this graph together, and this y-intercept. You don't want anything out too far. This thing could get too big. So, I don't know, go halfway between. Pick an x value of 2. Substitute it. Okay, x is 2. Right here. Substitute it again, just like we did up here for the zeros. You're going to substitute the 2 in there this time. And when you do that, you find that that point has coordinates 2, 0. So we're going to plot x is 2, y is 0, and this point is 1, 2 units to the left of the axis symmetry. Its corresponding point would be 1, 2 units to the right of the AOS. Okay, and then you connect with a nice, smooth parabola curve. Last one. Hopefully you did pause the video before. If not, you have an opportunity to pause it now and try this one on your own. Okay, so now I will walk you through this problem. So, because the leading coefficient is positive, this thing opens up. And when it opens up, you have a min. Okay, we need the axis symmetry. We're always going to use this x equals the opposite of b over 2a to find the axis symmetry. This is also the x value of the vertex because the axis of symmetry passes right through the vertex. We're going to identify the vertex and say it has coordinates -2, x is -2, and y is -9. Folks, this is the minimum point. The min happens at -2. The min value is -9. Okay, and again, you're going to follow. You're just going to do substitution. You know, this 2, this 8, and this -1 are my a, b, and c. I need the b and the a to substitute, to put into the formula to find the axis of symmetry and the x value of the vertex. After I find the x value of the vertex, I then take this value, -2, and I substitute it in for the x's to compute or calculate the y. Okay, and I get -9 when x is -2. So I plot my vertex. I find the y-intercept. Let the x be 0, and that's your c value is the y-intercept, -1. I plot it. You're going to use corresponding points. 2 units to the right of the AOS means 2 units to the left for a corresponding point. Choose another point. I would choose this point here, -1, right? This point here has an x value of -2. This point here has a y value of 0. I would go between. And how do you get the y for that? Well, again, you substitute it into the original function, right? The original function is, let me copy this down, y equals 2x squared plus 8x minus 1. Okay, so you're going to take your x value to -1. Don't forget about the squaring. Plus 8, -1, and then -1. Okay, this is a +1 times 2 is 2. This is a -8. 2 minus 8 is -6. Minus 1 is -7. Okay, so you do have to do some calculation. You always want to identify your vertex, your axis of symmetry. You want to tell if the function has a max or a min, where the min or max happens, and what the min or max value is. Okay, if you have any questions, let me know. Post a comment. so that I can help you. I don't know if you need help unless you tell me you need help. Have a great day.